Hey guys, this is Miss Sarah back with my next lesson. So here comes today's lesson. This is 8-2. And in this section, we're going to be learning about finding derivative of log functions. As we have decided in class, I hope you guys remember, we talked about we'll just do derivatives first and then we'll do integrals after. It would be easier to understand the process. So again, today it's another derivative lesson, but it's not exponential functions anymore. Now we're going to be taking derivative of log function. So here's the first rule. If you have to take derivative of ln function, then it would be equal to 1 over x. Means it's 1 over the function itself. So when I say the function, means it's the part that goes with ln function. So, but let's say this function is different than just x. Let's say it's ln of u. This is just like chain rule. If you remember how to do that, it's similar process. So I would do 1 over this function itself. Since this function is different than just x, it means I would multiply by the derivative of this u function, which is just the function itself. Trust me, once I'm going to show you with numbers, it's going to make more sense to you. All right, so here comes my first example. So if you want to follow along, you can go to page number 521, and I'm on first example. Example number first. You know, guys, sometimes I feel like this is so irritating listening to your own voice. Like when I watch my videos, it feels so bad. Like my own voice, it's kind of irritating. But anyways, we don't have any other option. So yeah, I have to do this. Anyways, here's the first example. I have ln of 2x in parentheses. All right. So first thing what I would do is I'll just make it 1 over the function itself, which is 2x. This piece here, so that would be 2x, and then times it by the derivative of this parentheses, which is 2, and at the end just put everything together, so this becomes 1 over x. Here you go, done. Another one. Let's say I have y is equal to ln of x squared plus 1. Again, same thing. I'll just put 1 over. So I have 1 over x squared plus 1. And now times it by the derivative of this piece itself, which is 2x. Now put it together. So this becomes 2x over x squared plus 1. Here you go. All set. All right, let's look at a few more examples on this one. So again, if you feel like there's anything you don't understand, pause the video and then go back to that step. So let's look at another example. I have x times ln x. Okay, so this time I see this function getting multiplied by another function, which is going to be product rule with this problem. So what I do is I'm going to do dy over dx, which is the derivative. Okay, so it's product rule. First one stays the same. Derivative of the second piece is over x. Now plus, now the second one stays the same, and derivative of the first one would be 1. Now rest is just simplifying. So let's put everything together. X is going to get canceled out, so I have 1 plus ln of x, and that's my answer. Here you go. One more on this one. So I have y is equal to, I have parentheses ln x and to the third power. Okay, now this is different than having ln parentheses and x to the third, because then x to the third would be just the expression itself. But now I see ln x inside the parentheses to the third power, which is different than this. All right. So for something like this, I would do chain rule first. So bring this 3 over. This becomes ln x to the second power. Time to take derivative of the inside piece, which is going to be 1 over x, because derivative of ln x would be 1 over x. Now put it together. So it's 3 ln x, but it's in parentheses. square and then over x. That would be my final answer. Here you go. Any question? Oh, I'm sorry, I won't be able to answer those questions, but if you have any, just put in comment and I'll answer that. All right, so I have a few more examples. So let's look at example number 2. You know what? I hope you remember expanding properties, because sometimes if you use those properties to find the derivative, trust me, it would make it way easier. So let's say if I have something like this, it's square root of x plus 1, all right? Okay, what I would do is I'll simplify first. So let's rewrite this. This is to 1/2 power. So now I know I can use expanding property, means I could bring this one on the front. If you put this 1/2 on the front, now this becomes 1/2. I have ln x plus 1. Now this is just normal ln function I need to take derivative of. So 1/2 stays the same, ln of this, so it would be derivative of this would be 1 over x plus 1. Time to take the derivative of inside, which is 1. Now if I put everything together, I have this. There you go. So to me, if you know those expansion properties, those properties are always going to make these problems way easier than normal process. So I made this square root into 1/2, put it on the front, and then just did normal derivative. Let me show you, I have 2 more examples, and that's all for today. So let me show you another one. So let's say I have ln parentheses, I have x times it by 1 minus x squared, and that, okay. Again, I'll just apply those properties first. So I know it's ln of 2 functions getting multiplied. So I could do ln of x plus ln of 1 minus x squared to 1/2. I hope you understand why there's a 1/2. Why? Because there's a square root. Now try simplifying. So ln x, this one I can put it on the front. This 1/2, put it on the front. This becomes 1/2 ln of 1 minus x squared. All right, time to take derivative. Ln of x, it's 1 over x. 1/2 stays same. Derivative of ln of this expression would be 1 over times it by derivative of this inside piece, which is 2x. Now time to put everything together. 1 over x stays the same. This one, I know I can cancel out the 2's. So I have x over 1 minus x squared. So now after this, it's totally up to you if you want to combine these fractions, or you could leave it like this. It's either ways it's correct. And yeah, here you go. So that's all. I have one last and almost there. Yeah. Bear with me, guys. I'm sorry. Too much math for this break, right? So, okay, so here it comes. My last example. I have ln of x squared plus 1 to the 2nd power over square root of 2x to the 2nd minus 1. All right, first thing what I would do is I'll apply expanding property. So I would do ln of x, this getting multiplied by this, so this becomes ln of x squared plus 1. So I hope you understand. So this 2, since it's the exponent, I'll just put it on the front already. I'm trying to skip that step. This is dividing, so it means this becomes minus. It's ln 2x squared minus 1. And I know it's going to be 1/2 on the top, which I can put it on the front. I hope you guys are with me. Again, if you don't understand this step, you can pause this video and go back. So what I did, I just applied expanding property. So now I have ln of x, derivative of that, 1 over x. This is 2 times 1 over x squared plus 1. Now time to take derivative of inside, which is 2x. It's 1/2 derivative of inside, which is 4x. Okay, time to put everything together. So I have 1 over x. This combined makes 4x over x squared plus 1. This, if I simplify, it's 2x over 2x to the 2nd minus 1. All right, so this is all. Again, you can stop here or you can combine these fractions, totally up to you. All right, thank you for watching, guys. Bye-bye.